Hi, I'm going to tell you a little bit about myself. I'm a mom, first thing. I won't get too much into that, but I did just send a kid off to college, and so that's pretty cool. I'm pretty excited about that. I just have one left. It's just a matter of time, and I'm going to be free. Anyway, I'm here as a developer today. I'm a team lead at where I work. I'm employed at Comcast, but I'm here today just to describe various developer experiences that I've had over my career. I've been a developer for 19 years now. I've done various things, various types of projects and code, and a majority of my career has been server-side Java stuff. I'm also an emerging speaker. So this is the 4th time I've done a talk. So I'm pretty excited to be here to do this. I'm also a self-appointed unconference advocate and promoter. I have to tell you a little bit about that experience because I feel like that's what made me and why I'm even here today. Does anyone know what an unconference is?
Is it where you have a conference, but you kind of write the topics on the board and you guys kind of, without organization, create the talks at the conference?
Yeah, basically. So no one has been to an unconference here. Is that correct?
We talked about sponsoring one, but we haven't done it. Okay. Tell us more and tell us what the next one is.
All right, absolutely. So an unconference is basically just that. It is not your typical conference. It is not a person like me up here behind a podium talking to all of you and everyone just sitting and listening and waiting for the talk to be done. It's not standing in line because there's not enough room for a session. It's not organizing all of your sessions, beforehand. I don't know if any of you have been to like JavaOne or CodeOne. Has anyone been to those conferences, a big conference like that? Well, a few weeks prior to the conference, they send out this huge schedule, and you've got to block your time out and sign up for the sessions. And a lot of times you might end up in a situation where you didn't sign up in time and there's not enough room, so you end up waiting outside the door to get in. That's not what an unconference is about at all. An unconference is not organized beforehand. Everyone shows up, and depending on who shows up and who's there, you decide every day what you want to talk about, how you want to break out into sessions, who's going to be in each one. And there is a session leader per se, but the idea is that there is not just one person speaking. You guide a conversation, and everyone is a contributor, and everyone talks, everyone discusses the topic. It's really amazing, and you can get really deep on subjects, and you are talking one-on-one with Java champions, with people that are experts in their field, and you learn a ton. Not only do you get this opportunity during the sessions, but usually an unconference is held in a really amazing place. And because of that, a lot of them are family friendly, and they feel like a little bit like a vacation. You can get together and go do activities after the sessions. And if you can imagine a bunch of Java nerds running around, even at the beach, you're laying there on the beach or even out in the water talking about Java modules or the latest problem with the garbage collector or any of that stuff. It's pretty incredible. So I'm wearing my JCrete t-shirt today. That is the very first unconference I attended. They are celebrating their 10-year anniversary next summer. It's going to be a pretty amazing time. It's a conference that's grown from, 20, 30 people up to over 170 now. I listed some websites of some various unconferences that I've been to. They're all in amazing places. JOnson is in Japan. It's in a different place every time, and usually centered around an onsen. JSpirit is in Germany. It is actually held at a distillery. And the sessions, you actually have sessions in the rooms with all of the wine barrels and everything. It's a really interesting place. Beautiful part of Germany. It's just south of Munich in a town called Hausen. Really quiet, really small. Yeah, that's a smaller unconference. If you haven't been to one yet, I would encourage going to a smaller one. JAlba is in Scotland. That's in Edinburgh. Amazing, just absolutely amazing, especially if you like whiskey. There's an excellent whiskey tour there. The last one I've been to is Lava One. It has been rebranded into Unboxed Hawaii, but it's still considered an unconference. And all pretty amazing places to be. They've been happening long enough and are popular enough that they are getting, they're valuable, and employers are starting to know this. So I've met people whose employers actually paid for them to attend an unconference, where in the past that was pretty hard to pull off, especially since there isn't a schedule beforehand. Now you can pull up previous years and look and see, what was talked about, who was there, what was discussed, and you can present that to your employer and get a little bit of help with travel and stuff like that. There is one I plan to sign up for that's actually in Crested Butte. They've been going on for several years. So that's a new one I want to add to this list next year. JCrete, though, is my ultimate favorite. I'm actually one of the unorganizers for JCrete. And so I'm obligated to go to the island of Crete every year. Pretty cool. The conferences go by the open space format, and there are very simple rules. And I'd like to apply some of these rules here tonight. And this is going to be kind of an unconference-y talk. I'm going to be interacting with you a little bit more, asking some questions. I want to get some conversation. And when we go out afterwards, we'll probably be talking more about this too. Whoever shows up are the right people. Thank you all for coming. You are the right people. You're the ones who are interested in this topic. You're the ones that are here. It's awesome. Whenever it starts is the right time, even though with technical difficulties. We start when it starts. Whatever happens is the only thing that could have. If I pass out up here because of nervousness, I'm sorry. That's just what happens. Wherever it happens is the right place. Really appreciate Pivotal for giving us this location so that we can come here and meet regularly. And when it's over, it's over. Don't, usually in the conferences, there's a set amount of time to discuss a topic, but if you're done, you're done. If you're finished with it, you're finished with it. Also, if you want to continue the conversation, you can go somewhere, continue your conversation, much like a Scrum, after Scrum meeting or something like that. But you want to keep the conference rolling. So all really, really good things, really successful ways to run a conference. So tonight, we are here to learn about service meshes. This is a talk that I've given a few times now. I gave it at CodeOne, and I gave it at Java Dev Day in Mexico in Guadalajara. Amazing community down there, by the way. There's a huge Java community down there. Really friendly people. Amazing conference to go to. They had over 500 attendees this last time. It's pretty amazing. Matt called me. I guess there was a cancellation here, and he called me and said, "Hey, Melissa, would you like to share your talk at the Jug?" And I'm like, "Heck yeah, definitely want to talk to you people and share, at least the things that I've learned and some of the struggles that I had with figuring out what a service mesh is and finding my way around and things like that." This is a pretty good introduction to what it is, kind of how it works, how the pieces are implemented and put together, that kind of stuff. And I really focus a lot on evaluation of it. Like, how do you know that this is going to work for you, or this is something that you should implement in your team? So always ask those questions as you hear me talk more about this. What I really want you to get out of this is just to be able to communicate intelligently with people about a service mesh, what it is. Don't get drowned in the terminology. I want you to be able to develop an opinion, again, whether this is for you or not, for your team. I'm also going to be giving you a ton of resources. So if you're interested in learning more, there's a lot of links in these slides that you can follow and go do a lot of the exercises, do some of the reading that I've put together in here. It's a lot of good information and really valuable. So yeah, if there's a place to put slides, I'll put them there, or I have them up on SlideShare as well. Yeah. All right, so first of all, I want to give you a little bit of a problem statement on how I got here to begin with. I'm a developer. I'm not an ops person. However, I've been recently put on a DevOps team. We're playing that game right now. How many devs do we have here? Okay, anyone ops? And then trick question, DevOps. All right.
We're for the state, we're starting to use DevOps.
Yes?
In terms of both, like with Azure DevOps, in terms of both Java stuff and .NET stuff, which is
Nice. Cool. I think it's been really valuable for me as a developer just to learn more about how things are deployed, how things are actually working together in production, rather than just having the narrow view of the code space, just to be able to understand how services communicate with each other, what the limitations are in the network. Things that I was really excited to learn more about is basically predicting, what kinds of resources you need under specific types of load. So being able to communicate more with ops folks and understand more of that and some of the restrictions that they live under, and understanding, where your boundaries are, it's been really valuable for me to learn that. That said, it's not perfect. There's definitely some kinks in the system that I think everyone has experienced at one point or another. But anyway, this is a story about a service. This is very simple. I simplified it as much as possible just to get this point across. But there was a service, and it just started misbehaving a little bit. And this is, in the middle of the night, just all of a sudden, one of these services, and what you see in green here, the green boxes, they're all the same. It's the same service. The orange box is a load balancer, and there are external requests coming into an endpoint that go through that load balancer and to these services. Okay? It's just very simple, round-robin type of thing. All of a sudden, services start dying. So as an ops person, what would you do in this situation? It's in the middle of the night. You're not going to be calling a developer. So what's your first thing that you would do here? Excuse me?
bounce it.
Bounce it? Okay. So that was tried, kept failing. What would you do next? Note that our ops did realize that there was quite an increase in the number of requests coming in. So as you can see on the left, times 100 requests. On the right, times 1,000 requests. So they did notice the load did increase. So what's the next option that you would do? Add more. Scale it. Right? It's pretty simple. And how many of you work in a Kubernetes environment? Okay. I'm just curious, do you have your system set up so they automatically scale when you hit load? Yeah? And do you have limits to that, limit set? Okay, so imagine this situation. This happened to not be in a Kubernetes environment, but imagine your situation. You've hit your limit. You've scaled as far as you can, and you're still dying. So now it's time to call a developer, which is expensive. So replicating the service did not solve this problem. Services were still dying. Part of my job right now is to triage problems like this, which is very difficult if you're working with a service that, especially if it's a performance and reliability problem, if you don't have good visibility within the system. This was a legacy service. There wasn't a whole lot that we could look at other than just raw logs. Okay? I mean, when I say raw, I mean, like we shipped them to Splunk or something. It wasn't that horrible. But that was all I had to work with. So I did, confirm that yes, there's a ton more requests coming into the system. But I realized that the bug might not be a code problem. It might be an architectural problem. All right? So the next thing to do with this, there's no way that I can simulate a full load in production. So the best way to deal with something like that is to make your problem smaller. I didn't think, because replicating didn't work very well, I did not anticipate that this was actually a load problem. It was something else. So do any of you, when you're trying to reproduce a problem, do you record some of your production traffic in order to use it, like in a test environment? Do you have systems that work that way? How many of you just, like, you're out of luck? You got to figure it out on your own. So that's kind of where we were. So I did, make the problem smaller and try to reproduce. But what I did do is look at some of the characteristics of the production issue, of the requests that were coming in. And what I found was that not only was there an increase in the number of requests, from end to end, a certain type of request was coming in. There was a lot more than we used to have of a certain type of request. So what I found looking at this system is that we had a single endpoint, and that single endpoint was bringing in a whole number of requests, but all of these requests were processed wildly differently. Some of them used a ton of resources and took a long time. Some of them were really quick. What we found is a lot of the requests that were coming in that were really quick, they were just dying. They were just, being rejected or timing out. Come to find out, looking at logs, and this is another problem, logs in production were not debug. So the smoking gun here was finding a debug log on a test system to figure out that these requests were all different and that the particular ones were timing out. It was pretty interesting problem. So given all of that information, how would you suggest we move forward with this? This is not going to be a quick fix. So what do you have any ideas on what you might do in a situation like this?
What type of statuses we are getting back?
Statuses, some were just, there weren't any 500 server errors, internal server errors. They were just timing out.
Okay. So is there a recent maybe caching?
Maybe caching?
Separate out, categorize your services, whether it's read heavy, write heavy.
That's close. That's close. And no, there wasn't a recent deployment to answer your question. It was just a difference in the type of load we were receiving. You have an idea?
Question
Okay.
for you. Were you guys behind a hardware-based load balancer or a software-based load balancer?
Hardware. Good question. Yes, but that did not work. Yes?
If you were identifying this as problem-specific types of requests, you should route particularly based on request type.
There you go. There you go. So this was a tiny monolith right here. Okay? And this monolith was doing too many things. So here's the next buzzword. We made a microservice out of it. So each request that was wildly different had a different service underneath. And because of that, now we're able to scale them differently. Okay? I promise I'm getting somewhere with all of this. So this, again, very simple. Two types of requests. One of them is really heavy. One of them is not. You route them differently. You scale them differently. Now, what's the problem here? You asked the question earlier that our load balancer, whether it was hardware or software. So this particular setup is not going to work, right? Hardware is not smart enough to route the specific requests to specific services. And for reasons and details I'm not going to share tonight, we did not have access to the load balancer, so that's the first problem. That's a whole nother team, right? And then we also could not change the endpoint that all of these requests were coming to. So that's when I sat down, and this was relatively new to me. I'm just starting in the architectural role a little bit and just learning how things are put together. And I know this is a problem that everyone has. I know that this has been solved before, so that's when I started looking for solutions. Basically going to Google, asking some questions, asking some other folks in the company, what can we do about this? So knowing that we need another layer between that hardware load balancer and all of our services, we need that layer to be smart enough, basically operating on layer 7 rather than being restricted like the hardware load balancer. We need that layer to be able to direct traffic to specific services, how we configure it. And we need control of that. We are not handing that off to infrastructure team and losing control of that. So does anyone have any idea what this might be? Close? It's, nope. Simpler than that. It's just software-based. It was just an API gateway. that was the first time I was introduced to just an API gateway. This was the simplest thing that we could put in. And like I said, this was a legacy service. This actually happened to be a service we did not want to invest a bunch of time and money in. And like I said earlier, developers are super expensive, so we needed to fix this fast. So doing the research at that time, and this was a few years ago that this happened. At that time, there were various products available that were just off the shelf that we could use. What we ended up throwing in, I think, at this time was like Express Gateway or something. It was really simple, really configurable. And it was the path of least resistance. Did not have to coordinate anything with the infrastructure team, really. And it was pretty efficient to deploy. During that research, I did come across Istio. Istio at the time was super young. It didn't really meet the requirements that I had at the time, and it wasn't even officially released or anything. So it was something I kind of looked at and then shelved. But being able to introduce this API gateway and learning more about that kind of software and how it works, it introduced a whole bunch of stuff for me, like being able to filter on various things. We were able to do Canary deploys we weren't able to do before. We were able to do blue-green deployments. We were able to just shut off servers if we needed to. Again, we weren't in a Kubernetes environment either. So that makes a difference for one of the reasons we went this way. So fine, everything was fine. We fixed the immediate problem, put out the fire, and then I think it was last Valentine's Day, Ray Sang came here, and he did a talk here. And Ray, if you don't know him, he's the Google Cloud Platform Developer Advocate. He talks a lot about Istio. If you've been to any of the big conferences, you would likely see Ray, and you'll likely see him talking about Istio in particular. He brought it up, and it had grown a lot since the last time I looked at it. I was super excited because I could just say, oh, I've heard of this before, I've read about it, and it definitely came to attend his talk. He was able to show some of the features and was able to do a live demo and stuff and put some stuff out there to show how things work. And it was pretty incredible. So after that talk, I'm like, that's it, I want to learn more about it. And what I really want to understand is how is it different than an API gateway? How is it different than what we had? Or why would we use something like Istio over the gateway that we had? So went out to the internet to see what it had to say, and I found this article by Zach Jory that explained some of the differences. And what's key here, and this cool chart that he put up, is that top item there. An API gateway handles north-south traffic, which is traffic from your external clients into your system. And then a service mesh is really dealing with handling east-west traffic. That is traffic that is already within your system, but between your services. So right away, there's a pretty big difference between these two. A lot has happened in the last couple years as far as the development of service meshes go, and there's a lot of common functionality now between an API gateway and a service mesh, and we'll probably see more of that come. And I wonder even if they might even just merge into one solution. Could happen. But for now, the intent, just keep in mind the intent is completely different here. North-south, east-west. So I still wanted to know what a service mesh was. Now that I understood how it was different from an API gateway, I wanted to know what it was. So went out to the internet again, asked some questions, tried to find a collection of definitions that made sense to me that I could wrap my head around. So here's one right away, whatis.com. What is a service mesh, I think is what my Google search was. A service mesh is a dedicated infrastructure layer that controls service-to-service communication over a network. This one makes me tired to say it. A service mesh is a configurable, low-latency infrastructure layer designed to handle a high volume of network-based inter-process communication among application infrastructure services using application programming interfaces, APIs. So a lot of words. That didn't help me very much. Here's one by William Morgan. William Morgan works at Buoyant. He's pretty great. Buoyant is actually the company that's behind Linkerd. And William actually reached out to me and said, hey, I really want to talk to you about Linkerd. I want to give you a demo. Really cool guy. I'm sure if any of you, reach out to him on Twitter or something, he would love to hear from you. His definition: a service mesh is a dedicated infrastructure layer for making service-to-service communication safe, fast, and reliable. That all sounds great. Another one, a service mesh brings security, resiliency, and visibility to service communication so developers don't have to. I really like that one. The developers don't have to worry about any of it, that it's all just going to be magically taken care of by this service mesh product thing. Lastly, the term service mesh is used to describe the network of microservices that make up such applications and the interactions between them. That is a definition from Istio's website. All of these are good. I just want a simple explanation. The best way I learn things is through analogy. So I went looking for something that reminds me of what a service mesh looks like or how it works, and came across the human circulatory system. I think that the most successful inventions and innovations have been ones that most closely resemble something naturally occurring in nature. And looky there, we've got a service mesh right there. Imagine all of those boxes being your services and all of the veins and arteries being your service mesh, controlling the communication between them, routing things appropriately, rate limiting, everything appropriately. So it seems pretty legit, right? So at this point, I'm getting really excited. Go out and start looking for, okay, what are all of the things that a service mesh is going to give me? And I came up with this list of items. There's quite a few things here. I want to go through each one of them so you understand the value of them and why we even care. Service discovery. Who can describe what service discovery is and why we need it today?
Sometimes, like, you want to stand up a service, but you don't want to have to hard code a host name into, you want to scale out. Just say, I just want the credit card service. I don't care which host is behind. Is that sort of like a...
There you go. Yeah, that's exactly it. Just to reiterate, service discovery is necessary today for a lot of environments because your services may not have a hard-coded IP or host name. In fact, likely they won't if you're doing dynamic scaling of any kind. You need to be able to bring services online when you need them, whenever you need them, and be able to take them out when you need to. All of that can't work very well if you don't have a good handle on service discovery, however you do it. Even if you have a little robot that sits in a room all day and hand codes those IPs in. But we found better ways of dealing with that, and that's service discovery. Service mesh, that's one of the features that a service mesh will give you, or at least they advertise that they will give you. Next one, observability. I think we can all agree on why you would need this. What do we need observability for? And by this, I mean you need to know when a service is up or down. You need to know when it's erroring out, that kind of stuff. Next one, rate limiting. Why would someone need rate limiting? What would you use that for? What's that? Back pressure. Very good. Yep. Any other ideas?
DOS mitigation.
What's that?
DOS mitigation.
DOS mitigation? Yeah. Prevent your services from getting overwhelmed, perhaps?
Why would you need back pressure?
We'll get to that one. Back pressure actually applies to another feature that works really well, and we'll talk more about that. Preventing starvation is one good one. If you have a lot of clients and they're all using the same services, you want to make sure that one of your clients isn't using all of the resources and starving the rest of your clients. Another reason could be a business reason, like maybe you have a subscription service where you sell different plans, and the plans have different performance, levels that you offer. So I'm going to move to circuit breaking. So back pressure it falls in line with circuit breaking. Do you guys everyone know what a circuit breaker is and what it does, why we have those in our services? Anyone want to offer up what it is? What is a circuit breaker?
It's a way to shut off a service early on before you can replicate to other services in your infrastructure.
Yes, exactly. That's exactly what it is. And you touched on the why there too, like why would you want to do this? You don't want one service failing to cause your entire system to fail. You want at least some of your requests to go through. So if you have a service that is misbehaving and it's just causing this domino effect, you need that to stop. So circuit breakers are pretty powerful pieces of software to put in that you can prevent situations like that. Now, if your circuit keeps breaking, you've got other problems. This is, last resort to save your whole system. Traffic shifting. Why would someone need traffic shifting?
Your original problem.
What's that?
Your original problem.
Hey, that's one of, yep. Canary deploys. Blue-green deploys. What's that?
What is a canary deploy?
A canary deploy is where you put in one service, let's say like a new version of a service that is compatible with old versions, but you only want to route particular traffic to it in order to test it, make sure that it works okay before releasing it to the general public. All right, load balancing. I think we all know what that's about, just making sure that one service doesn't have to do all the work. Authorization, authentication. Why is this important? Why do we care so much? I mean, it's a default thing to say, yeah, it should be secure. But what is this in the context of services speaking to each other? Why is this important? Go ahead. Metering?
Metering the service usage.
Okay.
For that, you need to know on whose behalf you're calling a microservice.
Right. Okay. Yep.
Maybe auditing.
Auditing. Okay.
Multi-tenant.
Multi-tenant stuff, yeah. Maybe you don't want some services talking to other services. I have a really kind of funny story about this. It's not really funny, it's pretty sad. I promise it wasn't me that this happened to, but I was there when it happened. Have you ever had a production environment polluted by your test environment?
That's what I was going to say. I always want to log in so that I know whether I'm in production or I'm in test.
There you go, yeah. That's pretty important. So we had a situation where we had a production AMQ broker running, okay, and it's queuing up tasks like it's supposed to do, and services are grabbing tasks like they're supposed to. Well, someone, just on accident, started up a service on their local machine and accidentally put that production URL of that broker in their config. Can you imagine what happened?
Publishing messages or consuming messages?
Consuming. They were consuming. So that took a while to figure out why some of our jobs were just disappearing. Customers were upset. We didn't know what happened. There's like no record of it. It lands in AMQ and then it's just gone. It took a while for us to figure that out. If we had a service mesh in there, and if we had, well, not just a service mesh would have solved that problem, but having it configured.
Have separate subnet.
Yes, having it configured so that,
VPC or something.
yep, configuring it so that test resources, even local boxes, cannot access prod resources. That would have been a good thing to start with, right? So remember that story next time you're setting up, awesome test environments and stuff. Make sure you protect your prod environment because it's an accident just waiting to happen. Another one is, databases. You don't want to start a run of tests that delete the database to begin with and have it accidentally connected to your prod database. That seems like a pretty obvious one, but it happens. I've seen it happen. All right, distributed tracing. Do we all understand what that is and how it works in a microservice environment? Okay, you can track a request, from service to service. You can measure how long requests are in a particular service. that kind of stuff. It's a pretty powerful troubleshooting mechanism. Yes?
What about connection management and exponential backup? Would you consider that part of observability?
Probably, yeah. Yeah, there's a lot of configuration that can be done that fall into these categories that would solve those problems or address those issues. These are just the ones that I cared about the most. Service Mesh actually offers a lot more things, especially like around reliability and stuff. We didn't talk about, retry mechanisms and things like that. Service Mesh will help you get all of that functionality. So yeah, these are all really legitimate solutions to all kinds of problems. And as I'm reading this and researching this, I'm getting all excited. Now, remember my original architectural problem? I kind of got a little bit in the weeds here because a lot of these problems I didn't even know we had, right? I mean, I was buying this hook, line, and sinker. This was an awesome thing. I wanted all of it. I wanted to be able to play with all of it. And I cared about all of these things, after reading everything and feeling like these are valuable things to add to our product. So I was asking myself, how come everyone isn't using a service mesh? How come in my group, in my immediate vicinity, there were so many people that didn't even know what it was or how to use it? Why isn't this just in everything right now? It just sounds wonderful. Well, then I came across this article. How many of you have gotten super excited about something and you're just confident that it's going to solve all of your problems and then your bubble gets burst? Either by, yeah. And it happens all the time. It can happen, with a senior engineer. It can happen with a peer. It can happen with your spouse, all of that. And it's not fun. It's not fun to go through, especially when you're really excited about something. So as I've gotten older, I'm getting more and more used to that. But so I don't know what the solution is to just not get as excited about things anymore. But just recognize that when you're talking to junior engineers especially, try not to step on that excitement too much. Anyway, this quote came out to me. If you're wondering about service mesh, you don't need one. After all my research and excitement, I came across this. Period. If you've reached the scale and microservice maturity level that requires a service mesh, you will be actively, perhaps desperately searching for a solution, and it will be abundantly clear that a service mesh is necessary. So that article gave me pause. There was another quote in there by a guy named Matt Klein. Anyone know who that is? Okay, I'll tell you in a second. I think we have a tendency to chase the shiny object in the sense that X company does Y, therefore I must do Y, even though I don't have any of X company's problems. That's pretty good. How many of you have gone to like a big conference and you hear about all these new things, or have developers go to conferences and come back to your place of work and you just want to implement everything right now? All these new things you've learned. We need to do them all. Someone was speaking, from Google. Well, they're doing it. We need to do it. Someone speaking from IBM. They're doing this. How come we're not doing this? Microsoft. You get all of these big names, and they're very good marketers. All of them are very good marketers. And that's what happens. So really, when you're coming up with problems like this, or you're trying to evaluate solutions, always go back to the problem you're trying to solve. And don't overkill the solution. It's not worth it. It really is not worth it. All right, so let's go back at that cool list. Take a look at it again. All of these things that we talked about, don't we do a lot of this already? Don't we have a lot of tools already out there? Probably most of you have these as part of your solution already without a service mesh. Can any of you name any of these tools? What was that? Okay. Yeah. Eureka.
Job for operation.
Yeah. Zookeeper. all of the like Prometheus and Grafana, Splunk, to have visibility in your product. Even commercial products like Datadog, it's pretty powerful. What about other proxies like Nginx, HA proxy, all of those things. So given that, what problem are we trying to solve here? We already have all these things. So Matt Klein is actually the Lyft engineer who started Envoy proxy. Envoy proxy is the default sidecar for Istio. And I'll explain what that means a little bit later. But I found this podcast by Matt, and he was being interviewed, and he basically describes how we got into this situation. Now, I'm going to describe this path. It makes me laugh because if you've been in this industry long enough, you've been an engineer long enough, you get this cyclical repeat. We have a monolith, we need to split it up. Oh, everything's split up too much, bring it all back in. You need to divide up all of your responsibilities and have other services do them. Oh no, that's too much. We need to get all of those responsibilities in one place so that our team can actually work on them in the same code base. So you'll see this in your career as you go. I don't know what do you think? It's like 10 years, every 10 years maybe?
And not just at the software level, I mean, everything.
Yeah, I'm pretty sure, don't bet on this, but I believe, probably in 10 years you're going to have a talk on why monoliths are so valuable. So Matt Klein described, initially we had the monolith. We decided that, this monolith is doing too many things. So you get the middle diagram where we split up the monolith into all these different pieces. Now, all of these different pieces could actually become wildly different, like even different languages, okay? And all of those pieces now have to all communicate with each other. And now you have all this extra traffic between all of your services. Now you've got to worry about things like security and all the things that we talked about, circuit breaking, all of that stuff. It changed also how teams are organized and how they build and deploy their services. So this isn't just a digital solution. This is also a human thing. This is a team management thing. So being able to get smaller teams and giving them autonomy over smaller pieces of code, this is another advantage of microservices that we all benefit from in some way or another. Well, I think the biggest problem that we were looking at was observability and reliability. Because of large numbers of services, this wasn't necessarily true in our particular example. But if you get a bigger set of services, you're going to have problems with different code bases, more interesting problems. You might have some services that have partial implementations of logging or even monitoring solutions. You might have some services fail because just one of them wasn't set up with circuit breaking appropriately. It gets pretty interesting. Also, you can have different communication protocols, different libraries. And some libraries are stronger in some areas than others. Standardization of logging or stats, that's pretty big where I'm at right now. And it's really hard to troubleshoot when you have to learn how to read the logs from each individual service. So it would be nice to have that standardized. All right, so let's look at how a service mesh is implemented. All of your service meshes out there that you go and look at, a lot of them, well, all of them, at least the ones that I saw, all of them use this sidecar proxy pattern. This is called the data plane of your service mesh. Every single service is expected to have a sidecar along with it. This sidecar is the thing that talks to everything else. It completely isolates your service from any external communication other than through that proxy. That proxy basically has all of the rules associated with it, who can talk to this service, who I'm going to talk to next. Basically, the proxy handles all of that communication and acts as the gateway to the service. Something worth noting here is a difference between the Service Mesh Linkerd, the first release, and the Service Mesh Linkerd 2. I'll get more into that a little bit later, but one of the biggest differences there is that the first version of Linkerd doesn't really require or follow this proxy per service pattern. There's some reasons for that, and it has to do with the code that it was written in and the memory footprint. It makes more sense for the first version of Linkerd to sit as a single proxy on a host rather than per service. That just was a more efficient way of doing things. There are a lot of systems out there that still use Linkerd in that way. Linkerd 2 is making rapid gains, but it was pretty much a rewrite of everything. So they had to come up with a lot of the features that Linkerd already had in their first release. So because of that, the first release of Linkerd is still a very active project and very actively used in the community. But just be aware that the sidecar pattern could be a little bit different for Linkerd. All right, so the other part of a service mesh is the control plane. This is what manages all of your proxies. It distributes all of the configuration, collects metrics, specifies your authentication policies, that kind of stuff. Usually there's some UI or CLI that you can use in order to do all this, in order to get your config out to the proxies, updating them all at once, or changing them however you need to get your services working appropriately. All right, so I'm getting my head wrapped around this, kind of understand how a service mesh works and what the architecture is. I'm ready to play with it. I'm sold. Any of you, so how many of you have heard of Istio before coming here? Okay, how many of you have heard of Linkerd before coming here? Okay, notice a lot more Istio out there than Linkerd. I'll get to that in a second. Where did you hear about these? Did you hear about it just from coworkers or conferences?
Subject lines info queue emails.
Okay, so, all right. Anything else? Just publications? Work? Okay. I threw Envoy in here. Envoy is just the sidecar proxy implementation that Istio uses. It's definitely worth taking a look at just to understand how that works and everything. Linkerd does not use Envoy. Yes?
How would these differ from like MuleSoft or Swagger? Would you even recognize
For a service mesh implementation?
Yeah.
So Swagger I always thought about like for documentation, like documenting your... Is there another service mesh offering?
So are these all open source?
We'll get to that. I'll go through both of them. So Istio, and I'll answer that right now. Both Istio and Linkerd are open source. Yes. Take some time to learn about Envoy. These are excellent starting places for learning about Istio and for Linkerd. You need to know a few things before playing with this. You do need to know a little bit about Docker, possibly Docker Compose, depending on how you choose to deploy. I think Envoy, a lot of their exercises, they did use Docker Compose. Pay attention to your versioning if you want to play with that. Docker Compose can be tricky if you aren't using the right YAML version. You need Kubernetes basics. I am not by any means a Kubernetes expert. In fact, we have entire teams dedicated to managing our Kubernetes clusters. And I really appreciate them. Really appreciate them. But in order to just kind of understand how these things work, because in this case, Istio and Linkerd are very heavily focused in a Kubernetes environment. So right away, if you're not in a Kubernetes environment, you might want to reconsider whether or not one of these service meshes makes sense for you or your team. You need to learn a little bit about Helm charts and templates, and then get used to YAML. It's not going away. It's going to be here forever. So get used to writing lists and lists of more lists, and make sure you indent appropriately. Get your Python perspective there. Make sure you've got consistency and indents perfect, or it's not going to work. Definitely, I use Docker for Mac here. There was a recommendation to up your CPUs. Definitely do that, or strange things happen. And then make sure you've got enough memory to work with on your machine. I'm lucky. I have an awesome machine. So I was pretty happy to get Docker for Mac to work. I was even able to go ahead and install like an Istio example and a Linkerd example and have them both running. But then I shut it down immediately because I got scared. But it's pretty cool. For Kubernetes, I did go out and I found this workshop type tutorial thing from Microsoft. It is really good, and I definitely recommend it. It says 50 days. That's just so that you don't go crazy. Obviously, each one of these items here don't take a full day or several days. A lot of them are just like videos you can watch or tutorials to work through. Certainly, it's not going to take your whole workday. So if you can just take a few of these at a time and start working through them, you're going to have a better understanding and a better foundation in Kubernetes. Day one really was enjoyable for me. It is written like a children's book. It is adorable. And if you actually go to this link here, phippy.io, you can even get like plushies of the characters. It's pretty awesome. There's another book. One of them is called The Illustrated Children's Guide to Kubernetes. That one's pretty good. The one that is in this exercise is this one. Phippy Goes to the Zoo. And basically, the background on Phippy, that's the giraffe, it's a PHP application. It's a metaphor for a PHP application. This zebra named Z is the nephew of Phippy, and they go to the zoo, and in each one of the little, some of these metaphors are pretty forced, so you just go with it, okay? This page is describing how pods work, and it's pretty enjoyable to go through. I'm obviously not going to go through the whole book, but I'm going to show you another one. This really made me laugh. This is the metaphor for daemon sets. Now look at that last line there. That orange word is not in the book, but I want to do an experiment with you. Okay, I'm going to read this last line, and when we get to that word, I want all of you to shout it out. And if you think you're pronouncing it right, be really loud. Okay, ready? Ready for this? All right. I bet that if we added a new pillar, a new bird would land on it faster than you could say.
Kubectl.
Very good.
Well, we had a talk on Kubernetes, and the guy that did it said it's Kubernetes control, but we say kubectl. So.
Yeah, and that's what the book said too. So I don't know. That kind of drives me nuts. The very first time I saw it, I'm like, kubectl or kube control. So kubectl, I didn't hear until I went to a conference and heard it pronounced that way. So yeah, I guess that's. I know. I wasn't keeping up with the program on these words. Just in case you don't know, that is the command you're going to use all the time when working with Kubernetes. All right, after each one of those sections, it does, lay out, it gets rid of the metaphor and explains exactly what they're talking about, just in case it didn't make it through, which I appreciated that on some of these. All right, let's start looking at Istio. So when I pulled up Istio and started working through some of the exercises, I just started taking notes. Yes?
Wait, so Phippy Goes to the Zoo, but what was the other book?
The illustrated, let's see. Let me go back. I think you're right. It is called The Illustrated Children's Guide to Kubernetes. And I'm sorry, that's in my speaker notes. I didn't put it on the slide. But remember phippy.io, because they're all there, all of those resources, and the plushies. I'm definitely getting a plushie. It's my reward for doing this talk. All right, so these are notes that I took when I started working through Istio, just putting down some of the things about it, making sure I understood what it's all about. It is written in Go. It is Apache 2.0 license, which I was pretty excited about. I'm like, yay, I'm allowed to use this. Designed for extensibility, but that might come at a cost. There are quite a number of deployment models that you can choose from. When you're starting out with this, you're going to want to just take the defaults, because there are a lot of ways to just shoot yourself in the foot and get frustrated. So the way that they have like an evaluation version that has all of the defaults put in. You don't have to worry about plugging in specific items or choosing things. You know, it's pretty opinionated. So stick with that when you're first learning about it. Otherwise, you're going to just want to wipe your machine, which happened to me. One of the things specifically is I did follow the instructions for installing Helm without tiller. And I don't know if any of you have done that, just using the Helm client. Just so you know, you don't need tiller to use Istio. You can install the client and be able to use Helm charts that way. Tiller has a problem with security. You can fix it, but by default, it's a real problem on your system. And it's just one more thing to install that you don't need. Also, Helm version 3 is actually planning on getting rid of tiller altogether. So if you can avoid even getting started with it to begin with, you're better off. It supports HTTP 1.1, HTTP 2, gRPC, and TCP. Great. That pretty much covers all services I care about. It's backed by Google, Red Hat, and IBM. So there's your marketing team right there. That's why I'm pretty convinced that is why most of you have heard of Istio. It's pretty popular. The community around Istio is pretty awesome. You'll be able to Google for help. They have really good help on their page and everything. Again, they have a quick install that's easy. I chose a different install, not so easy. I felt a little bit like choose your own adventure. Some of the instructions are circular if you don't use the default route, so be aware of that. And as I said, ton of online tutorials and everything. I want to actually show you. Whoops. This is always awkward to do this. So I've pulled up Istio's site right now. The reason I want to show you this, I just want to give you an idea of what it looks like. It's very straightforward. You can get something set up in 5 minutes. It's pretty cool. Like I said, I use Docker for Mac. You can also use, like Minikube. There's another one out there that I was turned on by called Kind. And it's a play on Docker in Docker, only Kubernetes in Docker. I thought that was kind of clever, so I wanted to try it out. Anyway, that seems to work pretty well, too. Down here in this tasks section, they have a ton of little things that you can work through to, understand how it works, play with it on your local backs. It's pretty amazing. I mean, there's counted over 40 examples here. So you can spend a lot of time messing around with this. Just make sure you're focusing on the real problem that you want to solve, right? Because there's a lot here. It's pretty heavy. All right. Let's take a look at how Istio is architected. This is the diagram you're going to see all the time. It's all over their page. It's shared everywhere in all of the documentation. It's basically the control plane for Istio is pretty heavy. I mean, there's lots of pieces and parts in here. Not all of these are required, and some can be disabled. There's some stuff in Mixer, too, that can make things a little more complicated. But basically, in the control plane, you've got Pilot. Pilot actually does the configuration of the data plane. The galley provides the configuration management services. Mixer interfaces with logging and monitoring solutions. And depending on what adapter you choose to use, you can actually write your own adapters and use something completely different or use what's baked, what they have by default. They really give you a lot of options to choose from. Mixer deals with quota systems, collects traffic metrics, handles some of the access control. Citadel is important. It applies certificates to each service. Good way to manage that. Communication is controlled now by your service identity rather than by your network. And then up, you have your data plane. So you've got your proxies. Again, it's a proxy per service, and it is Envoy, although it is their version of Envoy. You can actually plug in a different proxy. You can use Nginx if you wanted to. And that's pretty powerful. they give you a lot of choices, like I said. All right, let's take a look at Linkerd. Some of the things about Linkerd is written in Go and Rust. Linkerd, the first version, was written in Scala, so you get a little bit higher memory footprint there. And because of the problems with that and some of the critiques, Linkerd decided to go ahead and come out with Conduit, which was a lightweight service mesh meant for Kubernetes. When I went to go look for Conduit to figure out what it was, I learned Conduit is actually rolled into Linkerd 2. So they're one and the same. Conduit is written in Go, or sorry, Go and Rust. Rust is their proxy. It's a native proxy, so you can't. It's not pluggable like Istio is. You've got to use what Linkerd gives you. Linkerd is very opinionated. For example, Prometheus and Grafana are baked in. They've got some default dashboards that you can use that are pretty awesome. Again, they're also Apache 2.0 licensed, so that's great. They are the official service mesh supported by Cloud Native Computing Foundation. I don't know why Linkerd was chosen over other service mesh offerings out there, but it's something to note. They're not, that is not an organization that is run by any commercial company. The data and control plane are pretty tightly integrated. Like I said, they're less module than Istio. It was really easy to install. I kid you not, you don't even really need to understand Kubernetes or anything and how that works and go through their examples and be able to launch something and take a look at it. They basically, you just copy paste a lot of instructions and you're off and running in 5 minutes. It's pretty crazy. It is also intended for Kubernetes. They support all of the same protocols, HTTP 1.1, 2, gRPC, TCP. They weren't as feature-rich as Istio, and I did talk to you a little bit about that. That's partially because of the rewrite between Linkerd 1 and Linkerd 2. Linkerd 1 is very feature-rich, very nice. Linkerd 2, they're just catching up and getting everything up to par. I did have a talk with William Morgan recently, and there was an update just this October, actually. They released 2.6. 2.6 included being able to enable distributed tracing and a lot of traffic control stuff that I saw was missing the first time I gave this talk, and I was disappointed in. But they are moving really fast. They release a lot. Every 6 to 8 weeks, they have a regular release. Edge releases every week. They do have more room to grow. They deal with MTLS, but only for HTTP traffic. So they need, they're working on that, and that is on the roadmap to complete by the end of the year. This is the architectural diagram for Linkerd. As you can see, it also has the data plane and the control plane. Control plane is made up of 3 components. You've got your web UI component, your CLI component. You've got your controller. Inside the controller, you've got components like identity, which handles all of your certificate stuff. And then you've got a monitoring component, which is what I said earlier is their own version of Prometheus and Grafana that they have baked in the system. Pretty cool stuff. I want to show you their website. So there's no secrets here. So their documentation is also pretty good. I know, I don't know, maybe even 6 months ago, it seemed like documentation was kind of lagging behind the feature set, but they're pretty on the ball now. They're good competition right now. So they're making sure to get everything updated. They even have this latest release stuff. All of the documentation for it is in here already. Here, this is the getting started. Really cool stuff. The tasks, they also have a number of little tutorials that you can run through for to demonstrate each of the features that you care about. Pretty awesome. All right, so now that we know a little bit how they're made up and what their architecture looks like, I was really curious about performance. That's a whole nother talk in how to actually do testing on these things, it's a whole nother thing. So I'm not going to get into that. But this company, Kinvolk, it's a Berlin-based company, not associated with either Linkerd or Istio. However, Linkerd asked them to do this analysis. So if you can imagine, once this company came out with graphs looking like this, there's a lot of input from Istio. If you can tell on this graph, Istio is not looking as good as Linkerd. I mean, just, if all you want to do is read the graph, alone, that's the conclusion that you come away with, that performance is a little bit worse for Istio than it is for Linkerd. Linkerd has focused a lot on their latency, making sure that everything is really quick. So Istio was not happy about this. And one of the things that they came out with was that their evaluation version of Istio is comparing, oranges and apples, if you're trying to compare that directly against Linkerd. There were a lot of features that were enabled that probably shouldn't be in order to make it a better comparison, that kind of stuff. So Kinvolk went back and they went ahead and took a tuned version of Istio, which was provided by Istio, and then added that data along with the evaluation version of Istio. And you can see how that worked out for them. It's pretty disappointing. It was exactly the same. So if you want to read more about this, there's a whole website devoted to this. I put a couple of links here. They go into all the details on how these things were tested. They even go so far as to comment on the data center used to test these things and what time of day. It's pretty crazy. So if you want to get into all of that, there's a lot of information there to read. All right, so just a quick compare between Istio and Linkerd. They both support Kubernetes. They focus on Kubernetes. Istio advertises that you can actually use different environments other than Kubernetes, but I would not recommend that. It's not really well supported for Kubernetes is their baby, so stick with that. Both Apache 2 license. They both use that sidecar pattern deployment. Control planes for both of them are written in Go. They both support the same protocols. They both have similar traffic control and monitoring features, especially with the latest work that came out for Linkerd. They both support, Helm charts.
What is a Helm chart?
Helm charts, they're ways to, it's like a package manager for Kubernetes. So quick compare, again, some of the differences. Istio, their data plane is Envoy by default, which is C++, or you can choose Nginx, Linkerd. You definitely need to use theirs, which is written in Rust, just their native proxy. I kind of give them a little bit credit for using the native proxy. I think that might have a lot to do with their performance. They were really, key on that. Like we talked about the MTLS support, Linkerd has a ways to go there to make that fully usable. We looked at the performance overhead for each. They're a little bit different. In general, Istio is very pluggable and modular. They want to give developers as many options as possible so that they can get more use. Linkerd is pretty opinionated and tightly coupled, but the end result is it's a simpler implementation, easier to deploy. So what next? I only picked these two because I was pretty overwhelmed with even just understanding what a service mesh was to begin with. But there are definitely some other products out there that could be just as good that just don't have that marketing team behind them. So when you're looking at a product and you're looking at service mesh, definitely don't just jump on the bandwagon. Give these other ones a shot. I've heard really good things about the HashiCorp offering console service mesh. And Google is coming out with the Anthos service mesh, which I thought was pretty interesting. So in conclusion, choose a solution that addresses real problems you need to solve for your system. All of those other things that I listed, they're all amazing and wonderful, but you might not really need them. Consider your developers. Do they know Kubernetes? How comfortable are they with it? Do they understand all of that yet? That can be a huge damper on a team if they're told to, install a service mesh and you've got no one on the team that knows Kubernetes. Consider your code base. One of the big things here is, are all of your services homogeneous? I mean, are they all using the same code? In that case, you're probably better off just using the same libraries. Using the same code, the same libraries to deal with all of these cross-cutting concerns rather than introducing a whole nother layer there. There is this idea that using a service mesh that absolutely no code changes should be required for any of your services. You should just be able to layer the mesh on top and be done with it. But I did find that if you wanted to use something like distributed tracing, you might need to adjust your code a little bit. It has to forward the correct headers or it's not going to work for you. So consider that if you actually do need to make a code change in order to implement a service mesh for what you want. Consider the performance cost. In that, and I'm going to go back to it here because I want to point this out. Note that bare metal is always going to be faster. Anytime you introduce another layer, you're going to add latency. There's just no way around that. So if you're in an industry where you absolutely cannot add more latency, and I'll say, like, I'm in the media industry, so delivery of media is treated very differently than just the packaging of media, right? Delivery needs to be fast. Packaging, it's done when it's done, okay? Evaluate multiple solutions. Like I said, don't just jump on the bandwagon. And with that said, service meshes are pretty cool, just like your circulatory system. So it's definitely worth looking into. It's a pretty powerful space. There's a lot of movement going on there, so there's a lot of attention. Definitely worth knowing something about.
So I'm curious, you had read the quote by, I think, Emily about shiny new things. What made you overcome that and go, yeah, I'm going to check it out anyway?
So I'm lucky enough to work for a company that has a lab week. And it is an opportunity for developers to do just that. So you have an entire week where you can dedicate some time and look at some of this stuff. Now, that said, I'm a little crazy and I look at things late at night. I'm sure a lot of you do the same. So if I wake up at 3 in the morning, I might be, looking on my phone to read more about a service mesh because I'm curious and I want to be in the know.
And we have time for other questions.
Yeah, definitely. Yes?
So in comparing the service meshes, do you run across any things about, like, if you're in an AWS environment or Azure, is that to an advantage or disadvantage of either one of those?
I will say AWS has their own service mesh offering. So trying to use your own stuff within AWS is always going to have its own set of problems. And it's a pretty smart business. There's a lot of vendor lock-in there. So I did not choose to look into the AWS offering just because that was a no-go for me. As far as Azure, I don't have the answer to that. That's something that I would definitely need to look into. Some of these examples, like if you were to, I have seen stuff running like in Google Cloud, and it was pretty successful. So that I'm sure Azure is probably similar in that regard. Anything else? Yes?
Did you run across any service meshes that didn't require Kubernetes?
Linkerd, the first release, does not require Kubernetes. There are other orchestration frameworks that it can use. That was the only one that I found. I'm not saying they aren't out there. That's all I found. Yes?
Kind of related to that, so you approach this from a Kubernetes standpoint, that makes total sense. Did you look at this at all, or did you see any information about using serverless functions like AWS Lambda or Google Cloud Functions?
No, did not. Given that AWS has its own offering, do you think that might be the implementation of a service mesh in AWS? It could be how they're doing it. Yeah. Anything else? I'm waiting for someone to ask me what we did. Did we implement a service mesh?
Okay. So did you?
We did not. We did not.
What did you
We chose for each host, because since we were not in a dynamic Kubernetes environment, we chose for each host to stick an Nginx proxy on it, and that solved a lot of our problems. It was enough.
Are there any solutions that you might implement service mesh at your work?
Yes, we do have a monolith service that is ridiculous, and that would be something that I would like to tear apart, and that would definitely be something that I would look at a service mesh for, because each thing could be scaled. Yes, it's called job security, man. I'm still going to be employed in 10 years, and I'm going to be able to, I'm going to know something about all of this stuff. It's pretty good. Yes. Oh, I'm sorry. The answer to what we implemented? Oh, so what we chose instead was for each of our hosts, since we are not in a Kubernetes dynamic environment, we chose to put an Nginx proxy on there. And that solved all of the issues that we cared about. Yeah. Yeah. Any other questions?
Thank you very much. Oh, wait.
Oh.